Denser and rarer medium. Denser medium is the medium in which the speed of light is less. This means that denser medium has higher optical density, hence more light energy will be absorbed. Thus, the speed of the light is reduced. Whereas rarer medium is the medium in which the speed of light is more. Here, the optical density of this medium is less, so less amount of light energy will be absorbed, thus the speed of the light will be more. In the previous class, we have learned about the refractive index, that it determines the degree to which the light bends while passing from one medium to another. Actually, in the previous class, we also learned that refractive index is obtained by comparing the speeds of light in different medium. So, by comparison of a medium with respect to another, the refractive index is obtained. But generally, when we are talking about refractive index, we always compare the speed of the light in that particular medium with respect to the speed of light in the vacuum. Why do we compare the speed of light in vacuum? Is because the light travels fastest in vacuum. So the refractive index of a medium is the ratio of speed of light in vacuum to the speed of light in the given medium. This can be represented as refractive index of a medium equals speed of light in vacuum by speed of light in the medium, or n is equal to c by v, where n represents the refractive index of a medium, c represents the speed of light in vacuum, and v represents the speed of light in the medium. The refractive index of a medium is directly proportional to the optical density of the medium. This means that more the optical density of the medium, more will be the refractive index, hence more the light will be bending. Optically denser medium will have higher values of refractive index. For example, water compared to air has higher refractive index because its optical density is more. Here we can see that refractive index of water is 1.33. Refractive index of air is 1.0003, and the refractive index of vacuum is always considered as 1. Hence, we take the refractive index of vacuum, we compare the refractive index of vacuum with respect to the speed of light. Why? Because its speed is maximum in vacuum. Speed of light in vacuum and in air is almost equally, as we can see out here that air is 1.003 and vacuum is 1. So the speed of light in vacuum and in air is almost equal. So while comparing, when the speed of lights are being compared, generally we take the value of the speed of light in vacuum as 1. Diamond is one of the diamond is one of the object which is transparent medium and has the highest optical density. It has the highest refractive index because its optical density is higher, so its value in refractive index is also maximum. Here we can see that refractive index of diamond is equal to 2.42. This means that when the light enters diamond, it bends in such a way that the diamond starts shining. And this is one of the factor because of which the diamond shines. Next, we have the rules of refraction. We need to remember certain rules in order to find out how the light gets refracted. Number 1 is light bends while traveling from one medium to another. It does not bend if the light is incident perpendicularly or at normal. Let's have a look at the image. Here we can see that there is a line over here. This line, which is a surface of glass, and there is a air, and the light is getting incident on this surface from air, and it's getting inside the glass. All right, this line, which is perpendicular, as you can see the angle over here is 90 degree. This line which is perpendicular to the surface is called the normal. So this line is the normal, and as the rule number 1 says that light bends while traveling from one medium to another. So when this light is entering from the medium air to glass, the light is bending, and it does not bend if the light is incident perpendicularly at normal. Means that if the light is incident in this way, that means in this manner, if the light is incident along with this normal, then the light will not bend. The light which enters over here will directly, it will move on directly without any bending. So this is rule number 1. So let's have a look at the another picture or another image as well. So we have two images over here, in which in the first one we have the light entering from air to the glass, and in the second one we have the light going out of the glass into the air. So these are the two images which we will be referring in the coming points. Number 2, the rule number 2 says that light bends towards the normal when it travels from rarer to denser medium. So when we are talking about rarer and denser medium, again, air and glass. Compared to air, glass is more denser. That means air is rarer medium. So over here, light bends towards the normal when it travels from rarer to denser. So over here, the light is entering from rarer, that is from air, to glass towards the denser medium, and when the light enters, it bends in such a way that it gets towards the normal. It is not away from the normal, it is getting towards the normal. So light bends towards the normal when it travels from rarer to denser medium. Number 3, light bends away from the normal when it travels from the denser to rarer medium. Over here we can see that when the light is traveling from the denser medium to rarer medium, the light bends away from the normal. So this is the normal over here, and the light is bending away from the normal. It is not coming towards the normal, but it is bending away from the normal. Number 4, this is very important. These ray diagrams are reversible. As you can see from here that this light is entering the glass and getting bent out here. Suppose if we reverse the arrows over here, then this image is obtained. The image of this image, if by reversing the arrows we'll get this one, and by reversing the arrows of this image we'll get this image. So we can see that the ray diagrams are reversible. So over here you can see that when this light is getting incident on the surface, there is a small angle formed. This angle is called the angle of incidence, and when it refracts back, when it bends inside, okay, there is another angle formed between the normal and the refracted ray. This is called the refracted ray. So this angle is called the angle of refraction. Similarly over here we have angle of incidence, because this is the incident ray. The light which enters and strikes the surface first, that those rays are called the incident ray. And once the light gets refracted, once the light bends away, those are called the refracted rays. So over here this is the angle of refraction. All right, so the next we have the assignment over here. You will be doing this questions and answers. All right, then we'll start with the new topic in the next class. Thank you.